Database performance monitoring is an active endeavor that is done to find problems and fix them, as well as to find ways of improving database performance. Through various tools and interface, a database administrator can monitor the performance of various portions of the database serving different application and will be able to get visibility into the application's database performance through a specialized UI or a web interface. The benefits of database performance monitoring are as follows. One can determine whether performance can be improved, determine performance and security flaws by evaluating application and user activity, troubleshoot and debug problem in application component using the database. So in today's agenda, we will be seeing important key metrics of database server, some common scenarios for troubleshooting slow queries and disaster recovery, which are essential for database administrator or any IT team require the DR activity to be done or DR plan. We will also check performance metric of NoSQL database as a separate topic and finally see some analytical insight for reporting purpose, which is an important aspect of all management tasks that one can analyze the trend over time and evaluate the performance. So in any IT sector, the goal is to provide uninterrupted services, periodically monitor database performance, and eliminate any issues before end user reports to the concerned team. Along with this, analyzing the report will help in allocating resource for the future. It is hard to imagine any IT department without some dedicated databases, and in order to keep these databases up and running and error-free at all hours of need, it is important to keep them under constant surveillance. Also, organizations having complex infrastructure may use multiple databases for their daily activities or daily transaction. Database administrator not only would like to monitor the performance of database they use, but also would like to analyze a single or a set of select queries for any given database. So with the help of database query monitor, one can monitor the status of the query or monitor data out of that particular query. With this, let's start our first topic of the agenda, where we will see important key metrics which are common among RDBMS type of database. Starting with availability, where availability represents whether the particular database server is up or not and is able to undertake request. And health represents the overall state of the database server. So the health also depends upon the attribute that an administrator would like to monitor. Buffer hit ratio is one of the important counter which represents how often SQL Server is able to find data pages in its buffer cache. So when a query needs a data page, the higher this number, the better it is, because it means the SQL Server was able to get data for queries out of memory instead of reading from the disk. Another important attribute would be page life expectancy counter, which measures how long pages stay in the buffer cache in seconds. The longer a page stays in memory, the more likely SQL Server will not need to read from disk to resolve a query. Now, assume that there are a lot of requests going directly to the disk. So what will happen then? Obviously, the server disk I/O operation will increase and there will be performance bottleneck there. Likewise, we have another important attribute would be cache hit ratio. The metric measures how much the planned cache is being used. A high percentage here means that your SQL Server is not building a new plan for every query it is executing. So it is working effectively and efficiently. But a low percentage here means that for some reason, the SQL Server is doing more work than it needs to. Now, coming to the connection time, the time taken to connect to the SQL Server from Application Manager Server is what we show is as connection time, which is important metric. So if it is higher than this, there is some kind of issue. It could be a network issue or there are some lot of loads in the database server too. Login is a metric which is used for authenticating into SQL instance, while a user is used for authorization into a SQL database. One need to keep track of logins and logout. Both must be more or less the same count. If the logout count is very less compared to login, then we can assume that connection is not getting properly closed, or there are a lot of users logging into the database for request or waiting for a request to be completed. Again, another attribute is batch request per minute, which measures the number of batches SQL Server is receiving per minute. This counter is good indicator of how much activity is being processed by your SQL Server box. The higher the number, the more queries are being executed on your SQL Server box. Now, with this, let me switch to the product UI and show you the metrics that we were discussing. I have two tabs open for MS SQL and Oracle Server. Both are in the same installation. Just for ease purpose, I have opened it in different tabs. So under MS SQL Server, you can see the overview tab. Let me scroll down, and we can find the buffer cache, plan cache hit ratio, and we have other sub attributes that you can monitor under buffer manager statistics, like buffer hit ratio, page life expectancy, and under sessions, we can monitor the batch request per minute. Not only batch request per minute, but SQL compilation and recompilation is again one other attribute, important attribute, I would say. Likewise, in Oracle, let me switch to another tab. Under overview, we can show you the buffer hit ratio, the connection statistics, and the cache hit ratio and buffer cache hit ratio. Let me switch back to the presentation. Now, moving to our next topic in today's agenda, we will see a few common problems like connection issue, slow response, problem in retrieving the data, and metrics that one should monitor, along with disaster recovery monitoring. Now, when an administrator receives this error, first and foremost thought would be that whether the user has typed the correct credential. If yes, the next focus would be whether the network connection is up or not. Then the administrator or the user will try to troubleshoot other areas like firewall configuration, application configuration, or SQL Server configuration, etc., which is time consuming, right? So if an administrator knows what this error is, which is SQL browser service is down, with proper monitoring tool, one can restart the service automatically and save time. This we have seen in our last session on how one can use corrective action to restart a service automatically without one logging into the server manually and start the service. The next scenario is that a user is accessing an application, and via the application, he or she is requesting a record. Now, the slow response from a DB server could be because of not enough resources or queries taking more time to execute. Now let's see what are the metrics one can monitor to keep tab on resource and queries. When you create a database in SQL Server, data file and transaction log files are automatically created. The data file holds the data and objects such as table, indexes, stored procedure, and views. The transaction log file record all transaction and the database modification made by each transaction. So the transaction log file contain the information that is required to recover all transaction in the database. So it is important to keep eye on data and log file size. Now let's take a scenario. Assume that you receive an alert that the log file is high and you want to shrink that log file using the command. So how this can be done in Applications Manager? So using the execute command or script in the tool, one can shrink the database automatically once it reaches a defined threshold. So instead of an administrator logging into the SQL Management Studio and shrinking it manually, it can be done via the tool itself. In Oracle database consists of one or more logical storage units called tablespace, which collectively stores all of the database's data. Each tablespace in the Oracle database consists of one or more files called as data files, which are physical structures that conform to the operating system in which Oracle is running. Hence, monitoring used or free bytes, read and write, and data file auto extend, where you can set a table space to automatically extend itself by a specified amount. When it reaches its size limit, these are the few key metrics that needs to be monitored. Now, we have various scenarios. One is high CPU usage is very common problem in SQL Server. So in any query with a bad query plan can steal CPU time and harm system response. So with the tool, database administrator not only can monitor the average CPU time, but also get the actual query that are taking more CPU time or execution time. Likewise, we can able to pull the slow running queries along with the execution time and number of execution. So with the help of these metrics available, one can identify slow transaction in the query or database itself. In Oracle database, when Oracle requires a data block, it first checks to see if this data block is already in memory, that is database buffer cache. So if the data block is found there, Oracle will read it. This process is called as buffer get. The next is, if the data block is not found, Oracle will need to bring the data block from the disk into buffer cache first. So this process is called as disk read. So from Oracle database standpoint, the buffer get is logical I/O, where disk read is physical I/O. A buffer get may or may not require a disk read, but high buffer gets can cause high disk read, which causes I/O workload increase and I/O path bottleneck. So when accessing a table with a large amount of data or database buffer cache with insufficient size or combination of both, the SQL statement with high buffer get will also have high disk read, because not all data blocks will be able to fit in the database buffer cache and need to swap out to disk. Now let me switch to the product UI. Click on the MS SQL Server. So under database tab, we are showing you the various database that are running in the particular database. So one can monitor the data file size and log file size of all the databases that are configured. Not only this, we can directly go to individual database and get the data file and log file information along with other information like log flush detail, transaction detail, and underlying attributes pertaining to log flush can also be monitored. So not only this, we can also pull out the system table, the table relationship information, user table, etc. For example, let me click on the system tables here. This will fetch the system table name along with the total rows and the space used by that particular table. And this can be downloaded as CSV file too. So let me close this. And we have another tab, performance for MS SQL Monitor. Now here we have categorized based upon the bottlenecks that we find regularly in the MS SQL Server database. The first one is the top queries by CPU. So if I click here, I have an option to filter by and choose the databases that I want to look for the top queries that are consumed by CPU. So I can select the database and choose the filter. And if I scroll down, we can find the top queries by CPU along with the total CPU time or average CPU time along with execution time. Not only that, we can able to get the exact query which is getting executed in which database. So with this, we can able to understand if the query needs to be fine-tuned, we can ask the database or the application team to fine-tune the query so that it is not using the high CPU utilization. Likewise, we have top slow running queries. So this can be identified and fetched from the database server itself. So either we can use last poll data or top 10 dynamic value, and we can find the exact query that is taking a lot of time to execute or which are slow running. Similarly, in the Oracle database, we have a tab called as query. So when I click on the query, we'll able to see the buffer gets and the disk read. So with this, we will be able to monitor any slow transaction that is happening in your database server. Now let me switch back to the presentation. Now let's see a third scenario where a user is not able to retrieve data when accessing a particular record from a web application. The previous scenario is that user is able to get the record, but it is very slow. But this scenario is something related to blocking or waiting or lock. So that's what we are going to discuss more on this particular scenario. So in a SQL session in MS SQL Server is an occurrence of user interacting with the relational database through the use of SQL command. So when a user initially connects to the database, a session is established. So it is important to monitor the number of connection per host as well as the process ID that are consuming more memory or CPU. So when locks are held for a long period of time, they cause blocking. which means one process has to wait for the other process to finish with the data and release the lock before the second process can continue. So identifying blocked session is an important metric, and if needed, one can kill the session directly. In Oracle database, identifying the sessions that are online, offline, or invalid. Similarly, a table scan is when SQL Server has to scan the data or index page to find the appropriate record. The reason you would want to find and fix your scan is because they generally require more I/O and also take longer time to process. So this is something you will notice with an application that grows over time. When it is first released, performance would be great, obviously. But over time, as more data is added, the index can take longer and longer to complete. So tracking physical and logical read along with buffer cache hit will help you to identify performance bottleneck. So coming to the Oracle session summary, we can know session wait time and its corresponding events. Along with that, we can track the status and user account expiry date. Now, we will spend some time here in understanding waits. So, a resource wait is accumulated by processes running on SQL Server, which are waiting for a specific resource to become available, such as waiting for the release of a log on a specific record. The promise of WaitStat is to quickly identify where the most pressure bottlenecks are building within SQL Server. So resource waits are further broken down into 100 of specific categories. The exact number varies by version of SQL Server. So these categories are called wait types, so which enable you to determine a more specific bottleneck on a SQL Server, such as schema locking issues, planned cache memory pressures, or backup I/O problem, etc. The promise of WaitStat analysis is that you now have an excellent way to quickly determine where the strongest pressures are building up on SQL servers. An interesting aspect of wait statistics is that even on quiet server that is idle or not being used much, you will still accumulate wait statistics of various types. Some wait will by design accumulate minute of wait time every minute. This is because some wait just represent wait time and do not indicate any performance problem at all. Furthermore, a SQL Server performing only a light workload will also accumulate wait statistics. So if you just look at the wait stat, you might think that your top wait stat needs to be fixed, but no, there will always be a top wait. Let's imagine you take a look at a lightly used SQL Server hosting a SharePoint installation. Its top wait stat relate to LCK locking and FTS full text search. However, does that mean we need to get busy tuning the server? Well, not really. It is not busy after all. Now let's see a couple of wait types that are common across the MS SQL Server. The first one is LCK_M_S wait. So most people assume that if locking waits are the most prevalent, then it must be some kind of blocking problem that is the issue. Often it is such as lack of suitable non-clustered index causing a table scan in repeatable read or serializable isolation level that escalates to an S table lock. For instance, if the database is synchronously mirrored, then the transaction cannot commit and release its lock until the log record have been sent across to the mirror and returned to the mirror's log drive. So if the network is severely congested or there is a massive I/O contention on the mirror, then this could seriously delay the mirroring operation and cause the transaction to take much longer time to commit. So this would look like blocking. But the root cause is resource contention, which has to do with mirroring. Another wait type is page I/O latch share. There are indeed multiple kind of page I/O latch waits. The most common example are page IO latch _sh, which means share. This waiting for a data file page to be brought from disk into the buffer pool, so its content can be read. Another page IO latch examples are exclusive and update. So this will wait for a data file page to be bought from the disk into the buffer pool, so its content can be modified. Of these, the most common type by far is page IO latch share. So when this wait type is the most prevalent on the server, the knee-jerk reaction is to conclude that IO subsystem must have problem, and so that's where the investigation should be focused. The first thing to do is to compare the page IO latch share wait count along with the baseline. If the volume of wait is more or less the same, but the duration of each read wait has become much longer, then you would be concerned about the IO subsystem problem, such as misconfiguration or malfunction at the IO subsystem level, network latency. Another example would be IO workload causing contention with your workload, or configuration of synchronous IO subsystem replication and mirroring. So these are few problems that can arise when there is a IO subsystem problem. Now, imposing the lock over an object will cause any other process that impose a request against the lock object to wait until the lock is removed, so which will delay execution of that process. The state when a transaction is waiting for the lock to be removed or stopped is what is known as block. SQL Server is designed to work this way. As such, blocks are not inherently problematic. Therefore, only when a high level of block is detected on the SQL Server, or in a case in which block occurs that require excessive amount of time to be resolved, should it be treated as potential issue. So identifying such queries will help in releasing lock for the next transaction to take place. In Oracle, locks are mechanisms that prevent destructive interaction between transactions accessing the same resource. The database maintains several different types of locks depending on the operation that acquires the lock. In general, the database uses two types of lock. Exclusive lock. Only one exclusive lock can be obtained on a resource such as row or a table. And share locks. Many share locks can be obtained on a single resource. So here it is important to monitor the blocked session time. So if the session status is currently active, then the value represents the elapsed time in minutes since the session has become active. Similarly, inactive. Now, let me switch to the product UI and show you the options that we have. So let me first take the MS SQL Server. Let me go to the Sessions tab. And if I scroll down, I can see the host detail, the number of connections, along with the database connection detail, like the database name, the login name, and the number of connections. Similarly, we have session information. So here we are displaying the process ID along with the status and the memory, CPU, IO, or block. Not only that, we can use the filter by option. Let me slightly scroll up. We have session. We can filter it using the session log or block queries. So once we identify if there is any block, we can directly kill the session directly from the applications manager. Or if you just want to understand what is the query that are getting blocked and you want to do it manually, you can click on this plus symbol. That will show the exact query which is getting executed in the SQL Server. So with the help of the session tab, one can identify the performance bottleneck and try to rectify or remediate the issue. Similarly, let me scroll up and go to the performance tab. So here we can able to identify the most blocked queries or top queries by wait and waiting task. So with this, as I mentioned, so we have the waiting types. There are a lot of waiting types, and the topmost along with the waiting tasks and waiting time we fetch in the tool and show it here. So even for the wait types, we can click and get the data of the information on what wait types and what are all the queries that are getting executed. Similarly, average wait time or signal time is another attribute that one can monitor. Likewise, let me take you to the Oracle database and let me click on the session tab. So here we can able to identify the session details that are running. So this will give you a quick glimpse of the IDs that are running, the user, the CPU use, the memory sort, and the table scan. And if we scroll down, we can get the session summary, the machines that are connected, the number of connections, and the session wait and the users, like days to expire, the user profile, and the wait time of the session. So these attributes will assist you in identifying any kind of performance bottleneck. Now let me switch back to the presentation. Now the next topic is disaster recovery. So the disaster recovery is an area of security planning that aims to protect an organization from an effect of significant negative events or any unforeseen circumstances. So it is better to have a good recovery plan. And almost all the organization or the tool or the database tool they have, by default, they provide these options. So understanding performance metric of SQL backup set will help database administrator to avert any failure in backup process. For example, the metrics damaged. If the value is 1, then it means that the damage to the database was detected while this backup was being created. However, the backup operation continued despite the errors. There is another attribute, backup age, which displays the number of hours passed since the backup operation was completed. So with this attribute, you will be able to understand, or even the size is another attribute which we will able to understand, because down the line when you take the backup of the same database, obviously it's going to grow. So keeping a tab on size is also will assist you. Okay, there is an exponential growth in the particular database. So all these metrics can assist you in monitoring the backup states. Coming to the replication, SQL Server has log shipping option, which allows you to automatically send transaction log backup from a primary database on a primary server instance to one or more secondary database on secondary server instances. So here status displays the status of database log shipping. It could be starting, running, success, or error, or warning. And time elapsed in minute, which displays the total time taken to run the log shipping operation. So the time elapsed is one important metric that one should be monitoring, because if it is high, then obviously you need to check the network, or whether it's whether the log shipping has high number of data. So that elapsed time will help you to identify that information. Similarly, the replication. SQL Server replication is a technology for copying and distributing data and database objects from one database to another, and then synchronizing between database to maintain consistency and integrity. So there are three main components: publisher, which needs to replicate the data; distributor, that replicates data temporarily or stores the data temporarily; and subscriber, which consumes the replicated data, and it is necessary to tag the duration and alert if the duration is above the defined threshold value. So now, knowing the number of running backup jobs in the Oracle server will able to help you in identifying like how much backup jobs are running for the respective jobs that has been configured, and also keeping an eye on time taken for backup size, and also important metric to be monitored. So in Oracle database, there is an option called as log apply gap. This shows the difference between log sequence applied in the primary and standby instance. So Oracle database lets you save filled groups of redo log file to one or more offline destination. So this known collectively as archived redo logs, or more simply the archive logs. The process of turning redo log file into archived redo log files is called archiving. And delay is one parameter which can be monitored, to which identifies the delay interval before the archive redo log is automatically applied to standby server. So the time taken here is one important aspect that one can monitor in log apply gap. Now let me switch back to the present product and show you the metrics that we have. So let me click on the MS SQL Server database, and let me scroll up. So we have a backup and restore, where we are showing you the database name, the start time, the end time, the damaged attribute, and the backup hours. So we can configure the alarm and threshold for this. So in any unforeseen circumstances, if you need some alert to be raised based on the defined threshold, you will obviously get an alert, and one can troubleshoot the problem with that. Now let me go to the replication tab. So here we have the log shipping status, and the log shipping status for the database will be shown what is the agent that is running, and the time elapsed in minutes. So if it is higher, then obviously one can configure the threshold here for the status, and one can get the alert. Similarly, we have replication status for publication. Here we can see the status, the publications that are running, and even we can understand the running status, the performance if there are, and the duration. Similarly, the replication agent information can be captured. So the current status is one important metric that one can monitor, whether it succeeded, failed, or in progress, and can get alert based on that. Now, in the Oracle database, let me go to the second tab. We have jobs and backup. So obviously, there are jobs that are created in the Oracle database server. So based on these, the transaction will work. But let me scroll down, and here we have the backup jobs, running backup jobs count for the name, and the backup job details along with the session key, backup status, and time it took to execute. Even backup size can also be monitored. Now let me switch back to the presentation. Now coming to the third topic, big data is a term used to describe a collection of data that is huge in size and yet growing exponentially with time. So in short, such a data with so large an amount of information and complex that none of the traditional database management tool are able to store it or process it efficiently. So in an example that you see here, it's generic any-to-any data platform where you have multi-database vendor. Similarly, you have Hadoop technology, Apache Spark, and you have MySQL Postgres, which are RDBMS type of database, and Elasticsearch. So I'm not going to jump into and show you various metrics that one can monitor through Applications Manager for Hadoop, Kafka, or Elasticsearch or Spark. All these can be monitored in Applications Manager. Our primary focus here would be based upon the NoSQL type of database. So let's go to the topic. So first, let's see how resource utilization is important to monitor. So with the Cassandra memory utilization, one can monitor the free memory and used memory. Similarly, we have the number of used connection and available connection in the database server. So this will help to access the current load and capacity requirement of the server. Not only that, one can monitor the number of keys, number of key expired, because there are chances that some of the data in your Redis database is no longer used and taking up space for no purpose. So Redis schema-less nature makes it extremely difficult to make sense of your data sets content. Hence, monitoring number of key is important. Now, if you see the resource utilization, there are a few common attributes, but there might be some terminological name that may differ from database to database. But most of the resource utilization or the topics that we are going to see is going to be somewhat common between these NoSQL type of database or even the RDBMS type of database that we discussed. Now, coming to the slow transaction. So monitoring latency in Cassandra will give you a critical view of overall Cassandra performance and can indicate developing problem or a shifting in usage pattern that may require adjustment to your Cassandra cluster. And Cassandra slices latency statistics into number of different metrics, but perhaps the simplest and the highest value metric to monitor the current read and write latency. So Cassandra metric like write latency measures how much time it took to measure or required to fulfill a write request. Similarly, read latency measures the same for read request. So if we keep a tab on read and write latency, we'll be able to understand if there are any slow transaction that is happening in the Cassandra database. In MongoDB, which allows multiple clients to read and write the same data, in order to ensure consistency, it uses locking and other concurrency control measures to prevent multiple clients from modifying the same piece of data simultaneously. So together, these mechanisms guarantee that all writes to a single document occur either in full or not at all, and that client never sees an inconsistent view of the data. Now, asset is one important attributes that one can monitor in MongoDB. So MongoDB generate a document reporting on the number of each type of assertions that have been raised, such as message, warning, regular, user, asset. So here monitoring message assert, which indicates internal server exception, and user assert, which are triggered as the result of user operations or command generating an error like full disk space or a duplicate key exception or write error. So these important metrics can be monitored in the MongoDB server. Likewise, we have Redis, where we can able to understand the number of block client, and based upon the threshold value that we said, we will be able to understand, okay, this is the number with which the number of block clients are available. So with this, we'll be able to understand, okay, a lot of blocking is happening in the Redis database. So one can directly log into the Redis server and kill the block connection, or troubleshoot regarding the Redis database. The next is the disaster recovery. So what are the options that we have in NoSQL database is what we are going to see. So in cluster detail in Cassandra specifies detail on live, leaving, moving, joining, and unreachable nodes. And storage load in each node is one another important attributes that one can monitor. In MongoDB, replication operation counter, it represents the number of various database replication operations such as insert, update, delete, get more commands. So MongoDB instance, when it last started, we will able to get this information. So this value will help to analyze the load on the replica. In Redis, uses asynchronous replication. So with asynchronous, slave to master acknowledges the amount of data processed. A master can have multiple slaves. Slaves are able to accept connection from other slaves. Replication detail displays if the replication role is master or slave. So in case of slave, master node detail like master host, master port, and status of the link will be displayed. And slave connection specifies the number of slaves connected, and this will be plotted in case of master node alone. So let me go ahead and switch to the product UI, and let me show you various informations regarding the cluster environment or the NoSQL environment. So I'm going to take an example of Cassandra and MongoDB. So I'm opening it in a new tab so that I can switch back and show you the various attributes that we have for these two monitors. So under performance tab, as we can see, we can monitor the memory utilization. Maybe if you want, CPU can also be monitored. We have storage statistics and other stats that can be monitored. Likewise, in MongoDB also we have the server stats as another tab, and this will display the memory utilization, the response time, and network traffic. Now coming to the with respect to the slow transaction Cassandra, we have a key space detail tab. Let me click on it, and this will show you the key space information and latency information about all the key space that has been configured in the Cassandra database. So monitoring the write latency and read latency is important metric to be monitored. Similarly, in MongoDB, we have connection statistics, and we have asset errors information that one can monitor. And coming to the replication part, in MongoDB, we have the live node, moving node, and the replication insert errors that we have. Similarly, in the Cassandra database, we have cluster stats, where we can show the leaving node, unreachable node, and the node with the load. What is the load on each node? We can monitor that as well. Apart from that, there are other attributes that one can monitor too, like we have messages, other performance information, like we have request details that are coming in. Similarly, in MongoDB, we have the shard that can be monitored in the MongoDB server. Now, with this, let me switch back to the presentation. Now, we are on the last topic of the agenda, which is with respect to the reporting features that we have. So the trend analysis report can be pulled out of the tool, which can give you a quick glance report of the monitoring parameters or the attributes that you're monitoring in a particular database server. Likewise, one can pull a particular attribute report and understand the history, hour of day report, and statistical report from the report itself. And then we have an option where you can pull the database report and compare the report with another database server. So with this, you will be able to understand the growth trend between the, let's say one is performing good and another is performing bad, and both have the same configuration and same type of resources. So you can compare the value between the two database and understand what is the problem is or trend analysis is. The next important reporting features that we have is forecast reporting. So forecasting helps IT enterprise to predict future utilization based on current utilization trend and balance hardware cost with computing needs. The major objective of effective forecasting are staying informed about current usage trend and plan future utilization requirement based on forecast report. And another important aspect is dashboard. So one can build a customized dashboard for the database alone, or based upon the respective team or stakeholders, one can create various customized dashboards and monitor in real time. Generally, with the tool, you may get alert notification as soon as an event of any critical alert that occurs or warning occurs. So you will receive an alert, you have configured the threshold, all that are fine. But what if you want to get a quick glimpse of your infrastructure? So with the help of dashboard, you can build your customized dashboard and see various attributes or health and availability alerts in a quick glimpse. This can also be published and make use in your intranet portal too. Now with this, let me switch to the product UI and show you various options that we have. So let me take to the product. So under reports tab, we have on the left hand side, you can see the report categories. So first, starting with monitor group. Monitor group report can also be pulled with the at a glance report. So the monitors that are associated to the group, the metrics will be displayed. But our requirement here is to pull the trend analysis report of a particular monitor. So we can search for the servers that we have added, and we can pull the at a glance report. So this will show the at a glance report of the monitored attributes. Likewise, we can pull the trend analysis report for a particular attribute. For example, let's take buffer hit ratio. Now when we click, we'll be able to see the buffer hit ratio of last 7 days. We can also try to change it to last 30 days or custom time period or for 1 year. So we can get the minimum, maximum and hourly average of this particular attribute, which is the buffer hit ratio. And we can download it in CSV file, or we can download in PDF file too. Even you can schedule the report. That option is available. Now coming to the database server. So we have like server category, application server, we have database server. So here we can choose this option, whether all the database or specific database that you have configured, or between the same type of database, for example, MS SQL or Oracle database. So we can select that and pull the data accordingly. For example, like we can pull the at a glance report of all the database server. Let me pull out cache hit ratio, or let's assume, like, let me click on the buffer hit. So here we can see the monitors, various monitors that are configured, and we can select the monitors and compare the value. So this will help you to identify the average value between the two monitors that has been added in Applications Manager. Let me close this. And let me show you the forecast reporting, which is one important reporting feature, because the one which we have seen earlier, it's actually historical report that has been saved over the time. But forecast report is something different. It will predict the growth trend of a particular attribute and show you how the utilization would be after a certain period of time. So let me pull the data file size forecast report and show you that how the report will look like. Okay, so it has been in my machine. So let me, in this other screen, let me bring that up for you. So here is the forecast report for data file size in MB. Now here you can see that the filters we can use for last 15 days or 30 days we can pull out, and it's going to predict the growth trend. So it's going to show you how the growth trend of data file size would be after 4 months or 8 months or 1 year or 2 years. So with this you can plan the attribute, and in case if there is any performance bottleneck in a certain period of time, you can mark your calendar and make sure that the disk is having, or the data file or the disk has ample amount of space so that data file can be saved to the respective disk drive. So this is one aspect of forecast reporting. So let me just close this and go back to the presentation. And let me show you the importance of dashboard. So one can create as many dashboard as we want. So I have already created one sample dashboard called as database. So when I click here, I can see the Tableau data, the performance metrics. So here we are capturing the buffer hit ratio of MS SQL servers. Likewise, we can capture the recent 10 alarms that are generated. And we have Tableau data where we are capturing the log statistics of MS SQL Server. Likewise, we can create for Oracle, we can create for NoSQL database server too. Even if you want to add another widget, it's simple. We can just go ahead and click on the add widget that will give you the available widgets that we have in the tool and select out of it, and you can able to create the widget. Likewise, you can create a number of widgets based upon your choice. And the last option would be to publish the dashboard. So we have an option under Action tab where you can publish the dashboard. Let me scroll up. So the iframe is there. So you can use this JavaScript code in your internet portal, and the data will be displayed there. Now let me close this. Let me go back to the presentation. So with this, we are in the end of the session, and let's have a quick recap of what we have seen. So we have seen key metrics of database servers, RDBMS type, and various scenarios which a database administrator should keep an eye on, the metrics which are important to identify any slow transaction or any kind of bottlenecks or wait statistics. Now, we have also seen NoSQL database under big data technologies, and the importance of forecast database utilization and trend and planning capacity.